interpreting what the question is asking is the hardest part for most of us, okay? And that's going to go double for some of these type problems, just knowing what it's asking you for. But listen, you are going to start seeing this a lot because we work with solutions in chemistry, okay? So you're going to start seeing a lot of problems that are giving you molarity and volume, or talking about molarity and volume. So here we see molarity and volume. Here we see, that's a volume, isn't it? And molarity. So we're going to be seeing this. We just have to know how to interpret what it's asking and go through the correct steps to get there. But when you see molarity and volume, what formula do we know? How do we relate those things? M, that's supposed to be a big M, equals what over what? Moles of solute per liter, right? It is. Why is that there? You got me. It's recording. Hey. All right, so we know this. We know molarity is moles per unit volume. All right, and it's got to be liters. And we know if it's stoichiometry, what do we have to start with? A balanced chemical reaction, okay? What two things are reacting here? We've got something hydrochloric acid here. We got something silver nitrate here, okay? Can I write, you could write hydrochloric acid even if I didn't give that to you, I bet. But HCl, remember, is hydrochloric acid, right? Aqueous. All right, how do you write silver nitrate? Silver is always +1, right? It doesn't need a Roman numeral. And what's nitrate? NO3, which is -1. Okay? Aqueous. And I can predict products from that, can't I? This hydrogen from the hydrochloric acid, that's a +1, that's a -1. And what is that called? HNO3. Nitric acid. Very good. Very good. And that NO3, I can tell immediately that it is aqueous. Let's say it right since we're recording. Aqueous. All right. +1 -1, right? AgCl. And chloride is one of those halogens that's usually soluble, but remember it has some exceptions that make it insoluble, and silver was one of those. Good. I told y'all the rules would, if you used them and you kept using them like you were supposed to, they'd start sticking. Okay, and they do, but I'll still give them to you. Let me say this too. I know just while we were practicing and with our little quiz and stuff, you had some things that ended up being no reaction. The AP exam would never give you something like this that did not occur. Okay? So from now on, I'm not either. Now that we know the difference between what occurs and what doesn't, from now on, everything that I give you, you'll have a reaction for. Because what's the point if not having a reaction? Now that you know, okay? All right. What's the good thing about +1 and -1s all the way across the board? It's already balanced, right? Everything is 1, 1, 1, 1. Everybody see that? So are we good to go? We have a balanced chemical reaction, okay? All right. It wants to know what volume of this molar hydrochloric acid. Now, I can use this formula. I got the molarity. I want to know liters, but I got to find moles to be able to use that formula to find the volume, don't I? But look what it gives me about silver nitrate. It gives me volume and molarity. So can I, now that's a dilution. Can I use that formula to find moles of silver nitrate? The M equals, can I use that? And once I have moles of silver nitrate, can I go from moles of this to moles of this using stoichiometry? And once I have moles of that, can I plug it in and find the volume? Yes. This is not 7th grade math. Okay? This is a college course. All right, so what do I need to do first? I got to find moles of this, right? Because that's what I have information for. So The molarity of silver nitrate, it tells me, is 0.0500. Y'all with me?
Yes.
All right. I don't know mole. That's what I'm trying to find, but it gives me the volume. 50 milliliters. Can I leave it like that? Hagen, sit up. Can I leave it like that? No. I got to change it to liters, which means I'm just moving 3 spots or dividing by 1,000. 0.050. Okay? Tell me how many moles that is. What am I doing? It's just 0.05 times 0.05, right?
So it's 2.25.
Oh, yes. Thank you. Wasn't there somebody else, or are they already gone? They left you already. Can't remember.
I am, but I can't go to the induction because we have 2 softball games today, and we'll leave it at 1 o'clock.
That's right. See, that's what happens. Y'all are involved in everything. Bye, John. I wonder what they're having for lunch.
Oh, it's always chicken tenders and mashed potatoes, and a roll.
I'm fixing to go get on the bus. All right. What did y'all get that? Okay. Now that I know moles of that, now I can find moles of that using a picket fence, right? Okay. But look, this is, and I know these are all ones, and it's a 1-to-1 ratio, but we're going to do the steps because I said so. Okay? We've got 0.0025 moles of silver nitrate, right? Are you okay back there? Jeremiah needs a big table. Right. All right. Now I go back up here, right? Because I want to go from this part of the reaction to this part. Everybody see that? So I know for every 1 mole of silver nitrate, how many moles of hydrochloric acid? 1 again, right? These are all ones. And I know that, and I know we're just multiplying by 1, but we're going to do the steps anyway. So I also have 0.0025 moles of hydrochloric acid. It's all, we're using it all year. Yes, that's what, and I believe, I've said that many times, that none of that stuff, so no whining, okay, over there. It's not going away. Why did I have to find moles of hydrochloric acid? Why did I have to do that? So I can find the volume of it, right? Because now I know the molarity from the problem. I found the moles from stoichiometry, so now I can find the volume, okay? And the molarity from the problem was 0.204, okay? My moles were 0.0025, and then that's unknown, correct? All right, so what you get for X when you do your little algebra? You did? Look here. You can solve for X. Go for it. 0.012. That's what I got. Okay? Liters. And that is an acceptable, very acceptable, correct answer. If you were in the lab and you're having to measure out the correct volume, would you want to leave it in liters? No, you'd want milliliters for the lab, right? So, and it would just be, how would you change that to milliliters? Right, be 12 milliliters, okay? But this is the correct answer, units, everything. So see what I mean about problem interpretation, all right? And I better not hear a whine at all about the next one. And there's a typo, but you know what? I shouldn't even have to tell you that that's a typo, because you are very intelligent individuals. Well, most of us. Y'all see right here? That should be a decimal right there instead of a comma. Just my big old fingers typing, that's all. You know, they're right beside each other. All right, so now, here we go, problem interpretation. Let's read it and talk about this one, okay? What mass? Mass means I'm looking for what unit? grams,
So you gotta
okay?
find the moles
Well,
that are there.
hang on a minute. Hang on to that thought. You're not wrong, okay? When, confidence. See what I mean about having confidence? All right, 100 milliliters of 0.1 molar copper 2 chloride is mixed with 100 milliliters of 0.10 molar sodium hydroxide. Moles, I can find moles and moles. If you have amounts of two reactants and you want to know what mass of something's produced, what kind of stoichiometric problem is that? When you are given amount, or you have to find the amounts of both reactants to figure out how much is being produced. That y'all love to do, because you need two picket fences. It's a limiting reactant problem. When you have amounts of both reactants and you're trying to figure out how much is produced, remember, you have to see what you're being limited by. Okay? Oh, I'm fixing to throw something. What do you have to have first? Balanced reaction. Copper 2 chloride and sodium hydroxide. We can handle that. Can't we? Hagen, sit up. Strike two. Copper 2 chloride. Any argument about that? Okay. Aqueous plus sodium hydroxide. Na. Remember, +1. Yep. And aqueous. All right. Outside, outside, inside, inside. What charge did that copper have? It was a 2, right? Please don't write this. Why is that wrong? Because I have more than one hydroxide, I need parentheses around that polyatomic ion. And that is a very common mistake with hydroxide. Okay? Very common. All right. Plus, and I'm not sure aqueous solid yet. Some of y'all might know automatically because you've got your rules down in your brain. Okay? NaCl, that's +1, -1. And I know that sodium chloride is aqueous, right? Aqueous. I know it is. But remember, it's a group 1. That's that rule, right? Okay. What about this one? That's going to be my solid. Now, why is that so important? It says what mass of the solid is formed. Well, you got to figure out which one's going to be your solid first, right? Okay. So this is where I'm wanting to go. How many grams of that is going to be produced? Now, I gave you some simple numbers to make this one, even though it's several steps, they're easy steps, because look at all these ones I gave you. Y'all see all those ones? Okay. It gives me molarity. Remember I said you're going to see molarity and volume a lot. I can use molarity and volume of this to find moles, and I can use molarity and volume of this to find moles. Right? And then I can go from moles of this to grams of this using my picket fence. And moles of and it's not even as many steps as gram to gram, right? Okay. So let's just, oh, you know what? I forgot to do that last hour too, and they called me on it. Good catch. It is not balanced. I need some 2s, don't I? I need there. Is that good now? Very good catch. Now, the one above, it was all 1s. It doesn't matter. This one, if I hadn't balanced it, it would have messed me up at some point. Okay? Very important. Thank you. Good catch. All right. Molarity is moles, right, per unit volume, per liter, for the copper 2 chloride. And this is both going to be the same number because I have the same numbers, but I'm going to do it twice anyway. Okay? Molarity here was 0.100 equals moles, I don't know, over volume. It's in milliliters. I got to make liters, don't I? Which is 0.1. So moles of that really is just what? 0.1 times 0.1? And y'all double check, make sure you see how I got that. Need 0. And this just happens to have the same numbers, right? This is also 0.1, and is also 0.1 liters. So the moles of sodium hydroxide is also 0.010. So that makes this problem a little bit easier, because we're starting off with the same two numbers. Can I use a picket fence to go from moles of this to grams of this? Yes. And then I can use another one to go from moles of this to grams of this. Why do I need to? To find which one's limiting me, right? I'm not going to produce any more than the least amount that I get from my two picket fences. I can't produce any more than that. And this is easy picket fence. These are. Look, 0.010 copper 2 chloride. Oops, I need to put mole. And I know in my picket fence I can go from moles of this to moles of this, right? Because I've got a balanced reaction, and it's 1 to 1. We're going to write it anyway. Now, how do I get from moles of that to grams of that? What do I need to use? The molar mass, right? And I'm going to give it to you if you trust me. I know. I'd be kind of leery about it. You got me now? Okay. All right, y'all analyze this,
Molar mass
of this, right? And so basically it's just 0.01 times 97.6. Y'all got me? Oops, I'm not going to box that. From up here, that came from up here. Yeah, we're going to do that one next. Two moles of this for every 1 mole of that. So this is how much, if I have 0.010 moles of this, it would give me 0.976 grams of that. But I don't know if that's my answer yet. I need to see if which one of these two is limiting me, right? So now I've got to start with moles of sodium hydroxide. This is the same thing we've done before. It's not going away. For you to learn a new concept. I don't know how many students last year said, just when I thought I knew everything that I needed to know about that, you come and add something else. Because it's going to happen all year, you know. Just when you think we've got it, we're going to add some more. All right, so how do I go from moles of this, now this is what Hunter was just talking about, moles of this to moles of the copper 2 hydroxide. I've got to go up here, right? For every 2 moles of that, there's 1 mole of that, okay? 2 moles of sodium hydroxide. Oops. 1 mole. Well, and it's the same, right? 1 mole, if y'all still trust me. Because I'm going to, remember, you have to go to the same product. Yes, because you have to go to the same, both of them have to go to the same product. Yes. All right, let's just talk about that. What does this number give us? What does this little mathematical expression give us in the end? It's the same, 0.01 times this, but then I could divide it by 2, right? So it's 0.488 grams. Okay, what is this saying? This is saying if I have 0.01 moles of this and 0.01 moles of this, This is what this would give me, this is what, can I get any more than 0.488? No. Okay? So that's why I had to do this limiting reactant style here, because I can't produce any more than what I'm being limited by. I'm being limited by my sodium hydroxide. So if it wants to know the mass of the solid formed, that's how I would get there. Does that give me mass of solid? Mass in grams, right? And there's my solid. Okay? So, and this is what they said last hour, and trust me, I got this. I understand this completely. Well, yeah, I'm getting it now that we're sitting here going through this step by step, and you're helping us interpret what it's asking. But when I get a set of those on my own or on a test, it's not as easy. It's not the end of the world. The more we, and y'all have to trust me on this, it's just September still, okay? The more we do, the better you'll get. But you're not going to get any better if you're really struggling and you're not asking. I can't count the number of folks that have come to me and say, give me a few more of those problems. And I'll find some if I can, okay? Because they know the more they practice, the better they get. If you're not practicing and not doing, you know, be honest with yourself, you're not getting any better, okay? So just know it's not going away. I told you that. Okay. Are we okay with those two for now? That, because didn't that answer the question, right? What, mass of solid? Right? So that's it on that. The thing I said don't whine about is because you hate limiting reactants. Some of y'all hate limiting reactants because you got to do a picket fence for both. But that's just life. Okay.
Yeah,
Yes.
like what you said.
Yeah, I'm worried about that. All right, let's try this one. This is a college chemist. Remember, I try to give you a challenge one every now and then that I would not put on a test, but some of y'all deserve to be challenged. Okay? You got it. Tell me how I can take it further. But everybody's going to listen, and you're going to follow along with us. All right. A 1.42 gram sample of a pure compound with this formula. Now, there's no element that has a symbol M. So that's an unknown there that's part of this compound. Okay? Was dissolved in water and treated with an excess of aqueous calcium chloride, resulting in the precipitation of all the sulfate ions as calcium sulfate. The precipitate was collected. How would you collect a precipitate? Tweezers. Like filter paper, right? Can you pour it through the filter paper and the filter paper would hold the precipitate? I wouldn't try the tweezers. That probably would not work. The precipitate was collected, dried, and found to weigh 1.36 grams. Determine the molar mass of M and its identity. What do I have to start with? What do you have to start with? A balanced chemical reaction. Look, here's N2SO4. And what does it say it's being treated with or mixed with? Okay. Calcium chloride. Calcium's +2, chlorine's -1. CaCl2. See what you can do? See, don't just look at this and say, I can't do none of that, I'm skipping it. This is a major, you can do this, okay? At least start there, and then try to pick up the next couple of steps. All right, what here? What do I know about this compound? What charge does it have? It had a 1, right? And then chlorine is 1, so MCl, okay, plus Ca and SO4. This is a +2 and a -2, right? So they're going to reduce. All right. Do I know which one is solid? Which one is solid? It tells me, doesn't it? So I know that, remember I told you I'm not going to give you anything else that doesn't occur. So if that's my solid, that's my aqueous. All right, now what? That y'all caught me on last time. Got to balance it. 2. I think that's it. All right, so where's my, I'm just kind of looking at my unknown here and keep an eye on it. Okay? I'm not sure what that is. All right, what do I know the mass of? I know the mass, remember it said that I separated it out and dried it and it told me I had 1.36 grams of that solid, right? So I'm just writing down what are some things that I know. I know that. Can I get from grams of this to something I need over here? I can get to moles. Do I have to know the molar mass of that to go to moles? I just need that balanced reaction. Here's what I mean. I'm not putting this on a test. Y'all that understand it, my high achievers, I've got you in here. You know who you are. You know, you follow along, or you might be already almost finished with it. Okay? And Hunter assumes I was talking about him. I'm sorry. All right. 1 mole, how do I get rid of grams? I got to have my molar mass, right? Will y'all trust me on molar mass? I have grams. That's what I know about it. And I need to go to moles so that I can go to moles of this. And in my reaction, I got 1 mole per 1 mole. It's a 1-to-1. Don't ask. And if I multiply this through and divide by 136.14, I get 0.0100 moles of this unknown stuff. All right. I want somebody who knows some vocabulary here. I know moles of this. Does it tell me grams of it up there? So I have this many moles per what? So I have 1.42 grams of that substance. What is grams per mole? What is grams per mole the unit for? No, what's grams per mole the units of? It's something we've learned. We know it. We use it all the time. I just used it right here. Molar mass. All right, molar mass. So if I say 1.42 divided by 0.0100, then it tells me 142 grams per mole. That is what is that? What did I just calculate? The molar mass of what? Of M2SO4, right? Of that whole compound. So can I use that now to find out what M is?
Yes.
How?
You subtract the molar mass.
Right. That very, very good thinking. And this is like 96 or 96.1, and I get 46.1. What is that? What's that 96? That's the molar mass. Can I do MM? Molar mass of SO4, right? This is the molar mass of the whole thing. That's the SO4. Sorry. If I subtract the two, now I've got the molar mass of M2. Divided by 2, 23.05 grams per mole. Now can I tell what M is? Yeah, I just got to find the element that has that mass.
23.
Which one is the closest to it?
Sodium.
You go on, baby. You go on. Yep. Okay? So that's what I mean. We can use information. There's nothing there that you don't already know You just had to interpret that problem and use what you knew to get around and round and around to get to the answer. Okay? And I bet there's some of you in here that could have done that without me. I bet there is. Okay? All right, let's look at our closing.